I think I can see. That's okay.
All right, so what do you feel like is confusing right now?
Where, because sometimes I get confused when I keep on thinking I'm supposed to name the factors of them.
So it's the vocabulary factors versus multiples, right? Because sometimes you find the greatest common factor and sometimes the least common multiple. Okay, we can do that. All right, so right now, what are we working on now?
Here
What are we trying to find?
least common factor. I mean multiple.
All right, so yeah, our M are multiples. Okay, so one way that I always remember multiple, because it has the word multiply in it. So whenever we multiply something, if I was to take a number and multiply it, does that number get bigger or smaller? When we multiply, bigger. So that's how I try to remember multiply. Factor, I don't have something good to remember for that. I just always remember multiply that way. All right, so we skip this part here. So let's look over here since this is our practice, okay? We have a lot of space here that you can start listing your multiples if you need to. All right, so let's see if we can do the first one together. What are you going to do first?
List the multiples of 6.
Okay, 6, good. So how do you do that?
0, 6, 12, 18.
We'll stick with 4 and then see what happens. All right, what's next?
List the multiples of 3.
3, good.
0, 3, 6, 9.
All right. Now what do we do?
You have to find the least common factor, which is 9. 3.
So what are you looking for in both of these rows here? What are we looking for?
The least.
Well, look at over here. What did we do over here? We found the same ones. So do we see any matches in these rows of
No.
multiples? So we have 0, 6, 12, 18, and 0, 3, 6, 9. Were there any?
6.
All right, circle those so that we don't forget what number we're using. All right, so what does that 6 mean now? What are we using?
We have to use the 6 to multiply.
Okay, so our 6 is going to be what number in our fraction?
The multiply.
What are our two parts of a fraction?
The denominator.
Right. Right, so our 6 is going to be our what?
The denominator.
The denominator. Okay, so let's look at our two fractions. We have, what fraction is this?
The denominator.
And so how do we say this fraction?
2, 6.
All right, so what's our denominator?
The 6.
So that's right what we want, right? So we need to take care of this fraction. So let's write our fraction over here. And how do we make it so it has a 6 as the denominator?
You have to multiply 6 and 3.
Okay, so how do we want our end result, we want this denominator to be a 6, right? How do we get from 3 to 6? What do we have to do?
2
Yeah.
and 3.
So we multiply by 2, right? Okay, so multiply by 2. And so now what's next? What are we missing in our fraction
We
now?
have to do it to the top. now.
Exactly. All right, so what's our new fraction?
2, 6.
So 1/3 is equal to what other fraction?
2, 6.
2 6. Huh. How do we compare those two now? Sometimes what I like to do is I write an equal sign and then I write my new fraction right next to it so I can see it. Alright, so what did we learn about these two fractions?
That they're equal.
They're equal. That was a lot of work to figure that out, huh? I think that's what's sometimes hard, is that it seems like it's a lot of work. Alright, so this one We have to find that common denominator. So what multiples, what are our common multiples? So go ahead and list those out.
Zero, 5, 10, 15, and then 0, 6, 12, 18.
Do you see anything similar?
No.
So what do you think we should do?
We should try the top.
Remember when we compare, we have to get that denominator, the bottom number to be the same. So are these the only multiples of 5?
No.
Or could we keep going?
Keep going.
Why don't we keep going and see what happens? Alright, why don't you go to the bottom now too, to the 6's, and see what we can do. So we have 0, 6, 12. 6 times 3 is 18. 6 times 4 is 24. What's 6 times 5?
30.
30. Do we have anything similar yet?
The 30s.
The 30. So what's our new denominator going to be?
30.
Alright. So do we have to change both of these?
Yes.
Yeah, we didn't have to do that over here, but we definitely have to do it over here. So let's start with the 3/5. How do we get 5 to 30? How do we get the denominator to 30? What do we have to do?
Multiply it by 6.
Good. Right. And then numerator. Good. Great. So what's our new fraction?
18 30.
Alright, so that's this one. Good. Alright, now we gotta do 5, 6 and figure out what's our equivalent fraction for that. How do we get to 30?
Times 5.
Good. So what have we learned?
25, 30.
So what have we learned about these two fractions?
That 5, 6 is greater than 8, 30.
18 thirtieths or 3/5. Good. Alright, show me that. Alright, so I think that, I know you've only done 2, but I think you have a good handle. Can you tell me though, if we wanted to solve this, I'm not going to have you actually write it down, but what are the steps involved? What do we have to do?
Let's do the multiples.
Okay, list the multiples.
Finding the least common factor.
Multiple, remember, find whatever that multiple is that they both share. Good.
Multiply a number that gets to the least common multiple.
Good.
and then you have to, from that number, least common multiple, you times that to get to the brief number.
Right, so you make, like, this is called an equivalent fraction, so you make your equivalent fraction, and then what?
And then you becomes the fraction.
And then what do we do? Yeah, you look at the two to figure out which one's bigger and which one's smaller.
Yeah.
Good. All right. So I think that you can work on these on your own. Before you get down to where we have 3, because these are going to use number lines, come show me this if we're still working on math. Okay? Cool? You got it?
Yeah.
All right. Do you need help? How are you? Good. All right. So where are we at? So order from least to greatest. Check your answer using fraction tiles or number line. Why don't you bring your fraction tiles over? Okay. Perfect. All right. It's good to, I mean, I know it says in here it wants you to try to do, oh, don't do that yet. I saw your work. We may not have to do anything. Don't erase until you know for sure. All right, so let's see what we have first. Well, you did this one here, so let's look at this one. So we have 3/4, 2/3, and 7/8. Why don't we make those? Let's make like 3 lines. One that has 3/4, one that has 2/3, one that's 7/8. Tell me why you thought what you thought first.
So because I thought that 7/8 would be the biggest one because there's 8 pieces and 7 are like colored in.
Okay.
And then I thought 3/4 would be a big one because there's 4 pieces and 3 are colored in. And then this would be the least one because there's only 3 pieces and 2
Okay,
are
so you were looking at which number?
the
Here,
denominator.
the denominator. Okay. Did you try to make common denominators yet?
No.
Okay. Why do you laugh? Because that's what you did up here. Now we're just looking at 3 numbers. But yeah, why don't we go ahead and do that? Make your tiles. I think that using these resources, sometimes we get, especially if we're really good with math, we can just kind of do it in our head and get it done with. But sometimes seeing it too helps us later down the road. So always make sure you check your answers there. So you were looking at the denominator. How many more do you want? Just a couple more of these. What's it called? Thirds, right?
Yeah.
Flags.
2/3.
Oh, you need 2/3. Okay. Alright, so let's look here. Oh, wow. Your theory definitely works. So, if you think about, and you definitely numbered it, but I really want to think about,
Right? Like, I didn't understand. Like,
Yeah.
I tried to understand these.
I see that as erasing. So,
Yeah.
like, you started to think through. Let's first explain this, and then yeah, we're gonna go back up to this.
Yeah.
This idea of the denominator being big, because the other pattern. Look at these 3 fractions. What's kind of the pattern that you see with the relationship between the numerator and the denominator?
Kind of like one or like a couple.
They're 1 apart from each other. 2/3, 3/4, 7/8. So we know that they're more of the pie, more of the pizza. But you brought up a good point when you said this is the bigger denominator. And so your pieces, like you need more pieces to do that. All right, so your theory stands for this. And so let's keep that in mind. Do we see any other patterns like this anywhere? Let's see.
Kind of like this one, but this is all thirds, but this is like.
Oh, so what's the
4,
same here?
So all the numerators.
All right,
are
so
right.
let's use tiles to see what happens when the numerators are all the same, how we order them. So we need tens, just gonna take these out. 10s, 5s, and 4ths, right? All right, so let's get our 10s. And let's see what happens when the numerator's the same. Because I bet we could kind of like make a rule for it. Like, oh, when the numerators are this. does that mean for our numerator? All right, 3/10. Wow, it's really different than 3/4, huh?
Yeah.
All right, now 3/5. The green ones. What I like about fractions is like you have to look at the numerator and the denominator. Like you can't just look at one or the other. All right, so let's see what you thought. You said 3/4 was bigger, then 3/5, then 3/10. What does it tell us? I want you to think through. So we know the piece, the part of the whole is the same. So really, what did we have to look at to figure out?
Is the denominator.
The denominator. So because our numerator was all the same, what can you tell me about the denominator here?
The denominators.
If we
So
need a
it's
rule.
one apart. So you can't just look at like if they're all the same number, you have to see because.
All right,
like,
so
10
if I have the same numerators, if my denominator is a small number, what does that mean versus if it's a big number?
If it's a big number, it's small.
It's going to be a smaller fraction.
Yeah, and if it's a small number, then my fraction is going to be bigger.
It's interesting, isn't it? And you see how we can see it better this way too. All right, are there any other patterns on here that, I wonder what would
Maybe
happen.
this one because it's 5, 4, 3.
Okay, which
2,
was
1.
simpler. Oh, that's interesting. All right, let's look at that. Let's make that one too.
3.
Alright. So we got a lot, I mean, it's an interesting pattern, but I don't know how much it tells us about this. Whereas this one tells us more, doesn't it? What happens if and then obviously if all the denominators are the same, how do we order it if all the denominators are the same? If I have, how about let's write down, if I have 2/6, let's do it just like maybe right over here. If I have 2/6 and I have 1/6 and I have 5/6, how do I order that? What's my pattern there?
Well, so the smaller numerator. So this one was bigger. So the bigger numerator would be the smaller. Well, would be so the. So the bigger.
I don't have it perfect, obviously, because I don't have enough tiles. So if I was to say, okay, put these in order. 2/6, 1/6, 5/6. What would be first? What would be the smallest?
1/6.
How come?
Because there's 6 pieces, but there's only one.
Okay. What's next?
And then 2/6, and then 5/6.
Okay, so if our denominators are the same, how do we order our numerators? Least to greatest. Exactly.
Or greatest to least.
Or great, yeah, depending on how. Okay, good. Nice. All right, so which one do we want to look at up here? Pick one.
It's kind of stuck on this.
Okay, so we have 2/3 and does that say 6/9? I'm upside
Yeah,
down, and that's a weird number.
6/9.
Okay, so our goal here, what did we do over here? What was our goal? To do what? To
So-
find what?
To find if it's bigger or the common multiple.
So we wanted to make our denominators the same.
Yeah.
Okay, so how can we make our denominators the same? We have to use our multiples.
So it would be 3, 4,
Good. All right, next one.
18.
Perfect. Do we have anything similar?
9.
So our 9. So what is that 9 going to represent now? What are we going to use that 9 for?
So this would be times 3.
Mm-hmm.
This would be 9 times 3, 6.
All right, so what do we
So
know?
it's equal.
It's equal. So you were right.
Okay.
Nice.
And then this one. So I tried this one, but I didn't really
Well,
understand.
let's list our multiples.
Okay.
That's where we need to start.
Because I tried and I just did 4 multiples,
Well,
but
what do you think?
go more.
All right, why don't we do more? All right.
So here, 5, 7, I'm Anjali's sister.
I know. You tell her that I said hi. I sometimes see her when I'm at Red Lane, but I haven't seen her in a while.
Okay, so what do you need to turn the other cubes?
12.
You need to turn them into 6. So you know how to.
So there's still
All
my
right, so what do we do? Keep going. Sometimes we take a little while.
24. So this would be. But this is uneven number. This is
Okay,
1,
but
2, 3, 4, 6. 6, 7.
okay, but we know that both of those numbers go in because here it was uneven. It only took us once to get there, and it took us 3 times to get there. Okay, so we're not. It doesn't matter how long it takes you to get there. It's just can we get there. So what's going to be our new denominator?
So 30.
Good.
So now this would be times 6. That is 30 times 6 equals 18. Times 5 equals 30 times 5 equals 25. So this one would be this.
Exactly. Is that what you had before?
No, I hadn't thought of it.
Ah, got it. All right, good. All right, you work on these 3. If you want to take these, take them. I think that it's nice to use that visual, so we'll put these away. And keep thinking through these patterns. I think that's something that's important to fractions is understanding how they work by using patterns, by seeing those patterns. And making these different rules. All right, cool. Hey, Grace. I have that sheet that I keep forgetting about. Thank you. Do you still need help?